Well, g'day mate. Just thought I might take a little bit of video footage and show you what I've been up to with this router table and what I've put together. It's pretty close to being finished now, so just a couple of little jobs to be done and that'll tidy it up. Just a couple of fences to be put on the table and a couple of things like that. But I think I might have shown you this one. This is the terminal that I built. It's just got an old LCD screen that I had in it. And down the bottom I've just got a Pentium computer. It's one that I've had here for a few years. Totally wiped everything off it, right back to a clean machine, and all that's on it now is the operating equipment, the operating program for the router. Behind this little door in the front here is a pull-out drawer. Underneath it you can see a keyboard. So I try and keep it all pretty compact. I pull the keyboard out of here and put it up in front of the monitor. So that'll just sit up on the top here like so. And then I just pull this drawer out. This has still got to be painted at the moment. I haven't done that yet. So that gives me a bit of extra working area there to work with. And then when I finish with it, pack it all up, put a cover over it, and it doesn't take up too much room in the workshop. Just a standard wireless keyboard, standard wireless mouse. This other piece of gear is pretty cool though. This is it's a video editing unit. It's what they use if you're editing videos on your computer. All the buttons are programmable, and the wheel in the centre works like a jog wheel. So the way I've got it set up is the three buttons across the top here are the X, Y, Z axes. The buttons underneath it are the zeros for X, Y and Z. I've got a start button here, a stop button here, and these are feed speeds faster and slower. And then the wheel in the centre is what I use to jog the table around, and I'll show you that in just a moment. The software is one called Mac 3. It's probably one of the most common ones used between all the hobbyist type guys. It's a little bit hard to explain too much about it unless you're sitting here and having a little bit of a dumb thumb through it. But generally the top corner up here is where the code goes in after you've done the drawing. Then you've got the digital readouts of the X, Y, Z axes. The fourth one there is if you've got a rotary table on the deck, which I don't use, so it's not active at the moment. Over on the far right is a window where it puts up the drawing and it shows you where the cutter is running in relation to the drawing. Then in the bottom here you can change the spindle speed. I haven't actually got that feature connected up yet. I'll do that in some time in the future, but at the moment I'm just operating it from the drive on the spindle itself. Then you can adjust the feed rate, slower or faster from what you've got programmed in your drawing. And if you're using multiple tools, you can put tools in there and you can set datums of where the zero is for different tool lengths, etc. Then in the bottom left hand corner it's just got the start and the stop and the feed hold button and a couple of other features to work with your code. So it's a relatively simple program to use. It takes a little bit of getting your head around initially, but once you've got it sorted out, it works pretty well straightforward. The table itself is like so. It's just on 1300mm long. The actual cutting area though is the length of those white boards. They're a plastic board, just a sacrificial board to protect the aluminium deck of the router. In between them I've put some 8mm bolt holes down. They're all been threaded, so I can just put my clamps wherever I want it to clamp down to the work. The gantry, it's driven by two motors, one on the left and one on the right underneath the table. They run on a rack and pinion gearing type system to run the table back and forward. Sorry, the gantry back and forward. You can see this really nice track that I've used. It's linear track. And there's bearing blocks in behind here, running a series of roller bearings, a little bit similar to like a ball screw type setup. The balls continually roll around in a track inside the block as they run up and down this linear track. Really good for slop. There's absolutely no slop or movement in them at all, and the head of the thing is rock steady, which you need obviously for the accuracy. Same system on the vertical, on the Z axis. In fact, you can see the rack there that runs up, and then there's the pinion on the end of the motor there, just behind the cable. Micro switch there, just for the limit. This spindle motor weighs a fair bit. It's about 4 or 5 kilos, I think, from memory. Might be a little bit more. So if the power's turned off, there's nothing really to stop it from dropping and hitting the deck, which of course becomes sacrificial on your tool. So I picked up these gas struts from a four-wheel drive wrecker. I got 2 of them for $20. They're off the back window of a Jeep, and fortunately they're just the right pressure to hold the weight of the spindle motor up. So if I turn the power off for whatever reason, the spindle doesn't drop down and end up hitting your work or hitting the tool on the table. So that's worked out pretty well. On the back side of it, you can see the rack which runs on the Z-axis. There's the motor in the back there with the pinion sticking up, so that's what drives this along. The motor on the Z-axis at the top, and this cable chain, this plastic cable chain. All this shit comes out of China, mate. You buy it for nickel and dime sort of stuff. I think that cable chain was about $15. All the motors and the drives and everything's all come out of China. Same with the spindle motor. It's about the only way you can really do it cost effectively. So out of that cable chain is the wiring for the motors, the limit switches and the spindle, and they just come down the end down here into another cable chain which runs back and forth along the length of the table, and the cables all go into where the drivers are. Emergency stop button on the front. The little cupboard door on the left is just where I keep spanners and tools and collets, etc. This is the drive unit to drive the spindle motor. So it's variable frequency, which gives you variable speed, and in behind this door is where all the drivers are for the stepper motors. So it's all pretty straightforward. That's a 48-volt power supply there in that metal case, and you might have a little bit of trouble picking it up in the picture, but there's 4 drivers here, and these drivers are effectively controlled by this little breakout board down the bottom. And that is just connected to a printer port which goes into the back of your computer. So computer into this breakout board. The breakout board decides what pulses it needs to send to which of these motor drivers, and depending on the number of pulses, it just does the math and works out whether it needs to turn the pinion 1 turn, 2 turns or 10 turns or whatever it might be. Pretty accurate. I'm pretty happy with that. I've got it down to about probably 0.01 or 0.02 of a millimetre resolution now, so that's worked out pretty good. So that's about it, mate. I'll just show you the head running with this little drive that I've got, this remote drive. So if I push the X button at the moment and I turn the knob either left or right, you can see the head of the gantry moves in the in the X-axis left and right, and of course you can do very slowly. It's got about 7 different positions on this knob, so you can slow it right down. And then when you want to get to some really fine tuning on it, you put your finger in the middle here and you just turn that one, and it'll move at about 0.01 of a millimetre each time it does a click around. So it's very accurate. Then of course the next one is the Y button. I'll press that and it'll run back and forward on the table, and that's so you can position the tool to exactly where you want it. And of course the last one is the Z-axis, and the Z-axis is just going to control it up and down to get the cutter depth. So yeah, that's pretty much how we drive it around. And then of course once some programming is put in here, then you can just run it off the code. So for instance, you can see the scale on those digits. That's all in metric, of course. If I move the Z-axis up and down now, you can see it as the motor's moving up and down. That's the level of accuracy got. And then if I use that little center wheel, each time it clicks, that's how much it's moving. So it's pretty accurate. You can get the thing to as accurate as you ever want for the sort of work I'm doing with it anyhow. Alright mate, I'm just about to cut out some parts for you, so I'll cut those out and I'll show you the thing running around doing that, and I'll put this all on a disc and send it over to you. Alright mate, I'll catch up with you soon. See ya.